So our next conic section that we're going to look at is the ellipse. So just as a reminder, when we first started looking at conic sections, and we said that we're going to have these right circular cones and we're going to be intersecting them with planes, a circle is formed if the plane is parallel to one of the bases of the cone. So as opposed to getting a circle, we're going to get an ellipse if this plane is going to be slightly tilted, but it still only intersects one of those two cones. So for some definitions, they actually will consider a circle to be like a special case of an ellipse. So maybe let's look at why that might be a consideration. So very generic circle. Right, we'll center it at the origin. We'll give it a radius of 1. All right, so this thing would have the equation for this circle. X squared plus y squared is equal to 1, right? So what's going to happen then from like a circle to an ellipse, if we kind of imagine a very generic ellipse, is we're going to take a circle and we're going to kind of squish it. So here's just a very generic squished circle. In this case, I'm going to squish on it kind of by pushing it down, almost like sitting on it. Okay, so this is going to go out then. So again, we're just going to have this centered at the origin for convenience sake right now. So this is going to go out to A and negative A, and then up and down to B and negative B. So the relationship between these two helps you kind of remember what that general form of the ellipse is if you think about circles, ellipse is coming from circles, right? So if I had, an x squared and I had a y squared and I was adding them and I had a 1 over here, right? There's your very, very generic circle case. Right? So all we're going to do then to transform this into an ellipse is we're going to take into account these distances, these a's and b's that I go out. So in this case, I'm going to divide the x squared by a squared, and I'm going to divide this y squared term by b squared. And then that's going to get me my ellipse. So we can see then if a and b are the same value, or they're the same number, then we will just have a circle. Right? If I go out, side to side, the same distance that I go out, up, and down, I just get my special case of my circle. So when we're looking at ellipses then, generally then A and B will be a different number. So let's look at a little bit of a more formal definition of our ellipse. So an ellipse is a set of all points in a plane, the sum of whose distances from two fixed points, called the foci, in the plane remains to be a positive constant. So maybe as a separate sketch right here, right? So here's going to be my very generic ellipse. So I'm going to have these two values, these two special values in here, these foci, these points. And what's going to happen is that to any point on this ellipse, I'm going to have these two distances. These aren't actually radius because this isn't a circle, but maybe I'll just call this R1 and R2. So what's going to happen then if I do R1 plus R2, I get a constant. It does not change for any point that would be on this ellipse. Now, obviously, and depending where the point is, there's going to be, kind of a closer distance and a farther away distance. But the key thing is that those two distances, if I add them together for all points, ends up being this positive constant. All right, so when we're looking at these then, we will have a major axis of the ellipse is the longest line segment that passes through the center and the foci. So the center, let's dive into that a little bit. Okay, so if these are going to be the the foci, the center is the midpoint of the line segment. Joining the foci. So whatever this distance is, all right, we'll cut it in half, and that gets me my center. Okay, so the longest line segment that I can draw on this thing that contains the center and the foci, that will be the major axis. The endpoints of the major axis are called the vertices of the ellipse. Right? So in this picture right here, if this is my major axis, the vertices are always on the major axis. So that'll be a vertex over there, and this will be a vertex right there. So the vertices are a distance A from the center. Okay, so they'll live on the major axis, so whatever this distance is right here, from the center to get to that vertex, that distance is A. The minor axis of the ellipse is the shortest line segment that passes through the center. The length of the major axis is 2A, and the length of the minor axis is 2B. Okay, so if the length of the minor axis is 2B, then this distance right here is B. Alright, so the last maybe major piece of information was what's going on with these foci. So the foci are going to be a distance C from the center, where C is equal to A squared minus B squared. Right, so let's kind of summarize some of the stuff that's going on with an ellipse, and then we'll look at some examples. So for this first case right here, so one of the major things for an ellipse is keep in your mind that an ellipse comes from a circle. So if you can remember your equation for a circle, right, and again, I talked about a very specific case above, but the circle generic form is x minus h squared plus y minus k squared is equal to r squared. Okay, so if you remember for circles that there's this plus here, for an ellipse there's also going to be a plus here. So that's going to be important. And again, when you are dealing with these, the center is going to be at hk. H is associated with x, k is associated with y. Now when we're dealing with these, we are going to have the strict condition that A is greater than B, which is greater than 0. So we're not going to allow A and B to be equal, which would end up being not really an ellipse, that would be a circle. All right, we're going to say specifically one of those numbers has to be bigger than the other number. If your bigger number lives underneath your x variable, that means your major axis is going to be parallel to the x-axis. Right? So when you maybe look at this generic case, so this is going to be your major axis. So here's going to be my center. So major axis, remember that the vertices, right? So that's one of the vertices, that's another vertice. They live on the major axis. There's going to be two foci that are in here. They also live on the major axis, and this distance right here is going to be A, right, to get out from the center to your vertex. If it's the case where the bigger of these two values, the A, actually lives in your equation underneath the y term, in that case then your ellipse will have a major axis parallel to the y-axis. So then that would be your major axis. So again, we'd still have your center, the vertices still live on the major axis, and your foci still live on your major axis. Just now everybody's going to be moving then in the y direction. All right, a couple other things about this before we go on to some examples. I want you to notice in these standard equations, this number right here, it's going to be always 1. Okay? I will always have a 1 on these, which means then I may need to complete the square. And then the last thing before looking at some examples is remembering how to get these foci where the distance that's going to be satisfied is c squared is equal to a squared minus b squared. So we need to remember that when we're doing this here, it's going to be a minus. That's going to be a key thing because in the next section we're going to be dealing with a hyperbola, and then that's going to be plus, and we're going to have to remember the two different cases. So the way that I remember this is that I just remember when I'm dealing with an ellipse. Okay, so an ellipse has an S right here. I remember that I subtract A and B in this form. So this is where, again, it's important to remember that for an ellipse, the standard equation has a plus sign right here because it's related to a circle. But when I'm finding this foci, I have to remember this generic form. So on ellipse, I subtract my A and B values. Okay, so let's take a look at a couple of examples. All right, so for the first example, sketch the graph of the ellipse, and we're going to find some stuff like the center, the vertices, and the foci. So the equation is going to be y squared plus 9x squared is equal to 9. So the first thing I'm seeing is that both the x and the y are squared, right? So this is, telling me that I've got some sort of ellipse shape going on here, but we're going to want a 1 right here. So we're going to divide everybody by 9. And then it's generally a good idea if you look back up at these standard equations. In both cases, I have the x term always listed first. Okay, I think that's helpful. And then just remember your A is going to be whatever the bigger value is, and you just look at whether or not it's underneath the X or the Y. So I'm going to remove this around so the X term is first. So I'm going to get X squared plus Y squared over 9 is equal to 1. So maybe so I can see both values, I can write this as X squared over 1 squared plus y squared over 3 squared is equal to 1. So I can see then, because this value is bigger, that is going to dictate who my major axis is. So I'm going to have a major axis then that's going to be parallel to the y-axis. So also notice that nothing is being added, subtracted. Nothing is added or subtracted to those variables. Okay, so then this means this thing's center is going to be our very, very easy case at the origin, 0, 0. And then your A value is going to be 3 and your B value is 1. Okay, so remember, A is always the bigger value. It doesn't matter what variable it's associated with, A is going to be the bigger value. So let's see what we have so far. So come on over here, let's go ahead and start sketching. So I'm going to have a major axis along the y-axis. I got my center at 0, 0. So I'm going to go up 3, down 3, and then side to side I'm only going to need to go 1 unit. Okay, so I'm going to get these points. Oh, well, I want to go 1 unit, even though I put 2 tick marks down. 1 unit, there we go. Okay, so let's try to freehand this ellipse. There we go. So we've got the center. Maybe let's talk about those vertices next. So the vertices are always on the major axis, right? So here's my major axis. So they're going to be these endpoints. So I have vertices. Right, so this point right here is going to be 0, 3. This point right here is going to be 0, negative 3. So if I wanted to, maybe I could write it as 0 plus or minus 3. So there's going to be my vertices. And then last, for the foci, in order to get to the foci, I need to get that value for c. So we'll come down here. All right, so c squared. For an ellipse, we subtract a and b, so I'm going to get a squared minus b squared. And then notice that a is always going to be bigger, right, when you do this, so I'm going to get 3 squared minus 1 squared, or 9 minus 1 is 8. So if c squared is equal to 8, then c is equal to the square root of 8, which is the same thing as 2 root 2. So popping that into the calculator just to get an idea about how big this is going to be 2.8. All right, so what's going on here is that the foci, these are on the major axis. And we just found that the distance from the center to the foci is that value for c, which is 2 root 2. All right, so from my center, we're going to go up 2 root 2, which is about 2.8. So that's going to be f1. So as an ordered pair, that's 0, 2 root 2, and then we're going to go down to get the other foci, so that's going to be 0, negative 2 root 2. So if I wanted to write them maybe as a little bit cleaner, my foci are going to be at 0, and then plus or minus 2 root 2. All right, very cool. So let's jazz this up a little bit more, and let's get away from a center that is at the origin. So on this next one, the example is x plus 3 quantity squared all over 9 plus, and then y minus 2 quantity squared all over 4 is equal to 1. Okay, so this is going to then give me my hk. Remember, h is associated with x, k is associated with y. So for this guy, his center is going to be at negative 3, 2. Other pieces of information I'm seeing, A is going to be 3, B is 2, and my value for A is going to be associated with the x-axis. So because that bigger number is associated with the x variable. So remember, this is your a squared, and that's your b squared. So first you just have to find out which one's bigger so you know which one to call a and which one's to call b. Okay, don't get in the habit of always thinking a is going to be associated with the x. Right? So whatever number was bigger gets that a variable. So I'm going to need it eventually, so might as well just go ahead and find c right now. So c squared is equal to a squared minus b squared. The more you write these formulas, the more it'll help you remember it. All right, so c squared is equal to 9 minus 4, or 5. So c is equal to the square root of 5, which is approximately equal to 2.2. To help me with the finding of those foci. Alright, so let's graph what we've got so far. So I'm going to need to have a center at negative 3, 2. So I'm only going to be over here on the x-axis, but I'm going to need to go 3 left and right, 2 up and down. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, and I think that might be good. What do we got here? Negative 3, 2. Alright, so I'm going to go out 3, 1, 2, 3, get a vertex, 3 in the other direction, 1, 2, 3, that gets me my other vertex. Right, so my vertices are going to be at 0, 2, and at negative 6, 2. So my center is at negative 3, 2. So I'm just going left and right. That value for A. All right, and then I'm going to go up and down the value for B. So B was 2 units up, and then 2 units down. So there's your value for B. All right, so then we can sketch our ellipse. All right, so what do I still need? So I got my center, I got my vertices. Oh, that's not how you spell vertices. All right, we need the foci, right? So for the foci, again, they're going to live on the major axis. So your major axis is right here. All right, and it's going to seize the distance from the center to the foci. So from this center at negative 3, 2, I'm going to go 2, 1, 2, and a little bit more to the left. So that's going to get me a foci, and then 1, 2, and a little bit more. That will get me my other foci. So the foci are going to be at negative 3, and we added and subtracted square root of 5 to move left and right, and then but we didn't move anything in the y direction, so the y coordinate is going to be 2. And you can just leave it like that. Okay, so let's take a look at one more. Now on this one, right, they gave it to me all expanded out like that. So the first thing we're going to do in this is we're going to complete the square. And notice one of the things that as you work through these, you should start being able to look at that and identify like roughly what type of thing are you looking at. Are you going to be dealing with a parabola? Are you going to be dealing with maybe an ellipse, and a hyperbola? What sorts of things are you should be looking for? So I want you to notice on this, this starts looking a lot like a circle, right? Because I've got square terms on both x and y. So here's where I know you're going to be dealing with a parabola. So let's kind of complete the square and see what I'm seeing here to see, is this thing going to be a circle? Is this going to be an ellipse? What's going on here? Okay, so here we go. First thing is let's collect all the variable pieces. So the 9x squared minus the 18x, and then we'll figure out the completing the square later. I'm just going to clean this up. I'm going to put the y stuff together as plus 4y squared plus 16y. And then let's move that constant to the other side, so equals 11. Okay, so now let's start completing the square. So to complete the square on the squared terms, I need them to have a coefficient of 1, so I'll factor that value out. So I'll have the 9 sitting out in front, so I'll have x squared minus 2x plus some number. I'll fill that in a moment. On the y variable, the 4 will come sit out in front, so I'll have y squared plus 4y plus some number is equal to, and then the other side is 11. So let's figure what I got to put in these spots. So over here it's going to be negative 2 divided by 2 squared, negative 1 squared, which is 1. Okay, so if I put that over here, I need to add that to the other side. Oh, and it's not going to be 1, right? It's going to be 9 times 1. So I got to add 9 to the other side. Let's complete the square on the y variable. So again, take its middle term, divide it by 2, and square it. So I'm going to get 2 squared, which is 4. All right, so that goes in the blank. And then on that side, I really added 4 times 4, 16. So that's what I have to add to the other side. Okay, so let's clean this up. So I'm going to get 9 parentheses x minus 1 squared plus 4 parentheses y plus 2 squared is equal to, all right, 11 plus 9 plus 16 is 36. Okay, so the value over here, this must be a 1. Okay, so we're going to divide everybody by 36. And there's where when we start cleaning them up, this will actually divide nicely. So we'll say thank you. Okay, 9 over 36, I'll end up with a 4 in the denominator there. On the second term, I'll get the y plus 2 squared in the numerator. 4 over 36, I'll end up with a 9 right there, and then I get a 1. So the fact that I'm not getting the same number in both of these spots right here tell me I'm going to be dealing with an ellipse. So what do we know about our ellipse? All right, so this guy is going to have a center at 1, -2. The value for A is 3. The value for B is 2. And the major axis is parallel to the y-axis. Right? Because that A value was associated with my y variable. So let's come over here and graph what we have so far. So at 1, -2. So 1, -2. There's my center. So I'm going to need to go down 3. So 1, 2, 3. That gets me one of my vertices. If I go up 1, 2, 3, that gets me my other vertex. Right, so this is a vertex and that's a vertex. My vertices are going to be at 1, 1 and at 1, -5. So my value for B, we're going to go out 2 units from the center. So 1, 2, I'll put a tick mark right there so I can see where I am. Right, so 1, 2. But those don't get a special name, right? So we need those to help me graph this thing, but those aren't any special points. Okay, so try that one more time. Okay, and again, graph paper is helpful to make sure that your spacing looks good. Alright, so there's just my free-handed graph. Yeah, I'm really not liking that I didn't grab that point. Let's try this one more time. Okay, so here's my major axis. So we need to get our foci. It's going to be our last step. Alright, so c squared is equal to a squared minus b squared, or 9 minus 4 or 5. So c is equal to the square root of 5, again, which is roughly about 2.2. Right, so from my center up 1, 2 and a little bit more, down 1, 2 and a little bit more. Right, so those are going to be my foci. So we will have foci at 1, and then -2 plus or minus square root of 5. Alright, so that one was a little bit fancier because we needed to complete the square in order to get a better idea of what was going on there. Alright, so the next few examples are the detective examples. So they're going to give us information about what's going on with the ellipse, and we need to come up with the equation for it. So this first one is going to have the center is at the origin, foci at plus or minus 3, 0, and a minor axis of length 2. Right, so the center at the origin, so 0, 0, so that's going to give me my HK. Looking at the foci at plus or minus 3, 0. All right, so maybe let's just sketch that little piece of information. So if the foci are going to be at 3, 0, and -3, 0, so this has to be my major axis. So the major axis is parallel to the x-axis, which means the a squared is going to be under the x squared term. So I know a little bit more about generically how this is going to look. All right, so this is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Remember, it's always 1. So using the center being at 0, 0. All right, so let's go ahead and plug that in so we can see what's happening here, but a whole lot of nothing right there. Not going to add or subtract anything. So I need to figure out what's going to go here in the denominators, right? So next thing is they told me the minor axis has length 2. Okay, so maybe just sketch out a real quick thing on that. So if this is going to be my minor axis, right, and that has length 2, okay, so the value we want here is from the center to the edge. Okay, so that means then my value for b has to be 1. So that this entire length is then 2. So my b squared is going to be 1 squared. And then using that, the relationship between all of this stuff is c squared is equal to a squared minus b squared. C is the distance from the center to the foci. These are your foci. So this distance right here is my value for C. All right, so I know that. Okay, so I get 3 squared is equal to a squared minus 1 squared, which is 1. Okay, so I'll get 9 and then plus 1, which is 10, is equal to a squared. And we can just go ahead and leave it like that because I want a squared. Okay, so cleaning this whole thing up then, we'll have x squared over 10 plus y squared over 1 is equal to 1. If you don't want that 1 there, right, because dividing by 1 doesn't affect anything, sometimes it's nice to leave that there so you can very clearly see your b value, but it is not wrong to omit it. And just clean it up and write it like that. Alright, so last one. The center is going to be at -3, 1, vertex is at -3, 3, and the focus is at -3, 0. Right, so lots going on at -3. So let's do a quick sketch, see what we're looking at here. Alright, so -1, -2, -3, 1, 2, 3. Alright, so at -3, 1. So that's my center. Vertex is at -3, 3. So that's going to be one of the vertices. And I have a focus at -3, 0. Alright, so we know a lot of information, right? So since I'm given my center at -3, 1, I have my h and my k. I can also identify this is my major axis. So your major axis is parallel to the y-axis, which tells me that the a squared is going to be underneath my y squared term. Okay, so cool. Other things I know is the distance from my center to one of the vertices is a. It lives on the major axis. It's how far out you go from the center. And then the value for C is the distance from the center to the foci. Okay, so in this case, then my value for C is going to be 1. So using those pieces of information, c squared is equal to a squared minus b squared. So 1 squared is equal to 2 squared minus b squared. That means b squared is equal to 4 minus 1, or 3. So the generic form for these guys would be x minus h squared over, now the b goes associated with the x, right? Y minus k squared over a squared, right? Because a has to be associated with y. So that's going to be my major axis. Plus between those two guys is equal to 1. All right, so let's put in everything we know. So x plus 3 squared over b squared is 3, plus y minus 1 squared over my a squared, which is going to be 4, is equal to 1. And there is my equation. All right, so the last thing that we're going to look at is this idea about eccentricity. So the eccentricity E of an ellipse is defined as the number c over a, where a is the distance of a vertex from the center and c is the distance of a focus from the center. So maybe just as a quick sketch. Two different ellipses that are going to be very different. Okay, so we know then on the major axis, right? So from the center, you would get these vertices. So this distance from the center out to a vertex is a, and then the focus would be somewhere here on the major axis, and that distance is going to be c. Okay, so a is always going to be bigger than c because I always have to go further out to get to a vertex than I would have to go out to get to the focus. Okay, so when you build this ratio, you're always going to then have a smaller number over a bigger number, so that's going to get you something that's less than 1. Keep in mind that when you're working with a fraction, if you have the same value, both upstairs and downstairs, right, that actually gives you 1 exactly. Okay, so since a and c are never going to equal each other exactly, I'm not going to actually get to 1, but I could get really close to 1. So looking at this value for the eccentricity tells me a little bit about the shape of the ellipses. And we've been looking at some that you can see some of them are really kind of flattened out, that have these very pronounced major axis, and other ones have the major and minor axis about being the same length, and they start looking more and more like a circle. So maybe another way to think about the eccentricity is the eccentricity is the amount a conic section deviates from being perfectly circular. So this holds true for all conic sections, not just for an ellipse. So this is just right now we're looking at the definition of eccentricity as it's relating to an ellipse. So let's take a look at how these relate then. So if your value for C is really close to your value for A, right? So we'd be kind of looking at a situation like this. Okay, so then what's going to happen is your eccentricity is going to be really close to 1, and you're going to end up with an ellipse with a very pronounced major axis. So it's going to be very, very stretched out, either in the x direction or the y direction, depending on where the major axis is. For the eccentricity to be close to 0, what's going to need to happen is the value for C is going to have to be close to 0. Right? Because 0 divided by some number is going to give me 0. And A, this distance that we get to our vertex can't be 0, right? Because from the center, I've got to go out some sort of distance to get to this point. Right? Even on circles, we consider that to be the radius. So what's going to actually happen then is the value for C, the distance you get out to your focus, is going to be very, very small. And if that distance is very, very small, then you're going to get eccentricities that are going to be close to 0. So for the ellipse, it will have a shape that is very close to a circle. So then the ones that have the eccentricity about 0.5, okay, so then that's going to tell me, maybe one last sketch down here then. All right, so if I were to sketch this out, the distance from the center to a focus, that distance is going to be half of whatever this distance is. Okay, so this one, if you think about it, as it gets close to 1, this starts looking kind of like very squished. Right, really pulled out in that one direction. So these ones, maybe we would call these like kind of like a more balanced ellipse. So you got still a pronounced major axis, but also the minor axis is going to be very, very close to it. Okay, so when we're looking at these conic sections, we can then compute for these different conic sections how close they are to being perfectly circular. And maybe then it's helpful to know that for a circle, its eccentricity is 0. Okay, so the closer it gets to 0, the closer it gets to looking like a circle. The farther away it gets from 0, the more it starts looking like other shapes. Okay, so one last thing while we're talking about this is that this is not Euler's number, right? This isn't your E that we talked about, like with logarithms. That's not what's going on here. This is just being used as like a variable for this idea about eccentricity. So cool property that we look at when we're looking at conic sections.